All right. So now, excuse me. Now that we have defined the concept of conservative forces, the the question that remains is, so what? Why do we bother defining it? To see that, let's look at, well, gravity. I have a box, force of the weight, and as I go from one height to another, let's call this 0 and go from some height. As I go down, y is some height. Work of gravity is, because I'm moving in the opposite, in the same direction as the direction of the force, it's going to be W times that magnitude of that height. So gravity does this much work, and as you saw, because it's a conservative force, this amount of work probably means something special. And that is really what the potential energy is all about. Before that, maybe it's a good idea to define what really energy is. Energy, well, I don't know if I totally like this definition, but I don't have any other better definition. So let's go with this. Energy is capacity to do work. If some entity, something has capacity to exert force onto other pieces, we say it has energy. And now you can see why this concept becomes relevant. Note that when we have this object above the ground or above some reference height to a height y, just because it is higher up, as as gravity acts, the force of gravity brings the object down, it does work. So that means this amount is some kind of energy that exists just because we are above the ground. And this is the kind of energy we refer to when we say potential energy. So potential energy due to gravity, or potential energy in a gravitational field, is weight or mass times gravitational acceleration times the height of the object above a certain height. We usually actually use letter V, capital V, to show potential energy. And notice that if my object is below the reference, work of gravity kind of does negative work as I lift up my object. So in that case, it has negative potential. I actually have to do some work, put in energy myself to lift it up, to compensate for the lack or the opposite of potential energy that it has. So depending on the height, whether above or below a reference, you can have positive potential or negative potential energy. Similarly, when we were talking about another conservative force we talked about was a spring. So as we have this spring, and from its resting length, I can either stretch it or push it back or compress it. And in this case, just because the length of the spring has changed, I accumulate this capacity inside the spring to do work. And we saw the amount of work was related to 1/2 times the spring stiffness times change in length squared. So relative to that baseline, doesn't matter if I compress or stretch the spring. What letter do I use? E, I think. E is good for elastic. Potential energy stored due to elastic is that amount of work. And L is this. Doesn't matter you're stretching or compressing. Either way, you store some energy, some capacity inside your spring to allow it to do work. And in either way, you're storing positive value of energy. What did I want to say? Oh, note that this L here is calculated from resting length. And yes, that is the amount of potential energy stored in a spring due to its change in length. I think that's all I wanted to say here. One other thing, again, the good property of energy being a scalar, you can calculate total potential energy in a system, and V, you can add all the gravitational. Do I use G or do I use, let me see, I use G. All gravitational, let me change this. Gravitational potential energy plus all the elastic potential energy, possibly if you have other forms of potential energies, for instance, electrostatic potential and so on. You can add them up together to find the total potential energy of the system. So now we have defined general concept of energy. We have two forms of it: kinetic energy, we defined it before, and potential energy, we just defined it. We have the concept of work of conservative forces, work of non-conservative forces. Let's see how we can combine all of these ideas together. So I'll see you in the next video to do that.